Okay, so for first question, as we just mentioned, we have we want to find the wavelength of voice upper frequency, which is 3.4 kilohertz. So our equation, which is wavelength equal to a speed of light over the frequency. So the speed of light is 3 times 10 power of 8 meter per second divided by frequency 3.4 times 10 power of 3 hertz or 1 over second. We have 88.235 kilometer. So our next question is, what is the frequency of optical communication wavelength of 1550 nanometer? So we just rearrange our equation. So we write frequency is equal to the speed of light divided by the wavelength, which is 1550 nanometer. If we convert this to meter, means we need to multiply by 10 power of minus 9. So this become then in meter. So what we have is 1.935 times 10 power of 14 1 over second, or which is equivalent to hertz. So if someone put 1.9 times 10 power of 14 or 1.9 e 14 is the correct answer. So our next question is, what is the bandwidth of AM radio? So we refer to our slide number 63. We mentioned this. So we said the AM radio have a frequency started from 535 until 1605 kilohertz. So now we want to see what is this bandwidth. So we said the bandwidth is the upper frequency limit minus the lower frequency limit. So this is our F2, this is F1. So then we have 1605 minus 535, and we get a value of 1070. Since both of them are kilohertz, this is in kilohertz too. So this is then our last question. We have a communication system has 20 megahertz bandwidth. So the bandwidth is now 20 megahertz. The upper frequency limit means F2 of this channel is 108 megahertz. What is the lower frequency limit of this channel? So we said the bandwidth is F2 minus F1. Now we are looking for F1. Then we have F2 minus the bandwidth. So then we have F1 equal to 108 megahertz minus the bandwidth of 20 megahertz. So then this will be 88 megahertz. And this is for FM radio frequency bandwidth.